Hey, what's up everybody? Welcome to part one of my 3-part build series where I'm going to be turning a Kaku Voodoo 13-foot paddleboard kayak hybrid into a solar powered mini skiff. In this video I'm going to be showing you how I set up the solar system. I'm going to show you how I set up the solar panels with the battery and then get it connected to the motor. I'm going to be doing this off water. I'll have the trolling motor set up in a bucket of water with a watt meter connected to the motor speed controller and the solar charge controller connected to the battery. I'm going to let that run for a few hours after I show you guys how to put it together. That way I could show you how much power I'm consuming versus how much power the solar panel is producing. In part two I'm going to be showing you how I turn the kayak into the skiff. And then in part three I'm going to put it all together and go test it out on the water. So for this whole project, what you're going to need is obviously your kayak. You're going to need your battery. You're going to need your speed controller. You're going to need a motor. Those are the same parts that I used for my DIY kayak trolling motor setup. I'll have a link to that video down below. But you're also going to need a solar panel. This one is a Dokio 160 watt solar panel that I got off of Amazon. It comes with the charge controller. I have the charge controller in this waterproof sandwich box. I have the cables running through the side with some hot glue to keep it sealed up. It's not perfectly waterproof, but it's splash and rain resistant. This is a charge controller. It regulates how much power is going from the solar panel into the battery. That way you don't destroy your battery, because this is an 18-volt solar panel and it's only a 12-volt battery. This charge controller does allow you to switch between lithium polymer, lithium iron phosphate, sealed lead acid, and AGM batteries. But as you saw, I will be using a lithium iron phosphate. This is just a 150 amp watt meter. It goes up to 24 volts. I'm gonna have that connected in between the battery and the speed controller, and it will track total power consumed as I'm running the motor. I'm also going to be installing this swivel seat. You could get the seat and the swivel. It's just a Swivies seat mount that I got off Amazon as well. I could put a link to that in the description. You could use the seat that came with this kayak, but in my opinion it's one of the most uncomfortable seats I've ever sat in. It's basically just sitting on a metal box with a really thin stadium pad on it. So I'm going to be switching to the swivel seat. That way I could turn around and whatnot as well. You're going to need a sacrificial cooler. In the next video I'll show you what this is for and what I'm going to do with it. Then you're going to need some insulation foam board. This is closed cell foam, so by itself it's more or less waterproof and floats, but I'm going to be making pontoons out of that and then fiberglassing the pontoons so it stays completely waterproof. So you'll need some fiberglass mat and some fiberglass resin. That resin will eat through the foam board. Before you apply the resin on the fiberglass, you're gonna need to coat the foam with this paint. This is a latex based paint. I've already tried a little bit of it on the foam. It does not dissolve it. When you're looking for paint to coat your boards, you want to make sure that it doesn't have any kind of petroleum based solvents in it. You want it to be water based if possible, and the latex paint prevents any moisture from soaking through it, so the fiberglass resin will not be able to penetrate the paint and start dissolving the pontoons. In addition to that, you're going to need some aluminum rails. These are just going to be used on the side of the kayak to connect the pontoons to the kayak. I will likely just be using this rail system that's already on here to connect them. And then you'll just need some various tools. You need a razor knife so you can score the foam to break it into smaller pieces if you need to. I have the circular saw set to 47 degrees to try to get these angles cut in the edges of the foam. And then I'm using this Ryobi saw thing that the blade just moves or shakes back and forth quickly. And I will show you what that is for in the next video. But that's everything you're gonna need to do this project. This is just a 4x8 foot piece of foam board that I got from Home Depot. It's 1 inch thick, and what I like about this one is, as you can see, it's pre-scored. It has a 16-inch section on either side, and then down the middle it has 2 8-inch sections, and it'll just break cleanly down where the score line is. For this project, I'm just breaking them into 8-inch wide sections for the pontoons. That's how tall it's going to be. The pontoons will serve a few purposes. They'll give me a wider platform to lay the solar panel out across, because the solar panel is a little over 6 feet wide when it's opened all the way. and the kayak is only 3 feet wide. So I'm going to need to extend the kayak out a little bit. The solar panel itself is IP67 rated. So the cells and the panel is more or less waterproof or highly water resistant. It does not have the charge controller built into the system. It has this ASE connector that runs to this 9-foot long cable that comes out of the charge controller, also with an ASE connector. Having it done that way makes it to where you can keep the charge controller in a waterproof container without having to worry about rain or splashes from being out on the water ruining your solar panel. In addition to providing the extra width I need for the solar panels, it will add extra stability, so you could stand more easily on this kayak and you could sit up higher without having to worry about falling over. Now I'm going to show you how to put together the solar system so you could use it out on the water. Okay, now that we know what the plan is for the kayak, I'm going to go ahead and get started on the solar portion of this project. And as I said before, to do this, you're going to need a motor, a battery, a motor speed controller, and the solar system. This particular solar system comes with a solar charge controller. And again, I just have it in this waterproof box. So what you're going to want to do is get your solar panel opened up. Then, according to to the instructions that came with this solar system, the first thing you do is connect your battery to the charge controller. It came with these alligator clips and a couple other options. So there are other ways to connect to this. If you don't want to use the alligator clips, I just use that cable for convenience. Then you're going to want to hold this for 3 seconds and switch it until it gets to B4, and then long press until it stops flashing. B4 is for lithium iron phosphate. After you have it connected to the battery, you're going to take the 9-foot cable that comes that comes with the kit, connect this wire directly to the solar panel. So now that we have it connected, you can see that it is charging the battery at 14.4 volts, which for a lithium battery is where you want it to be. So you can see it's set up, connected, and the sun is out. So next thing I'm going to do is connect the charge controller. I'm going to be doing that with this watt meter just so I could track how much power I've consumed. Get the battery output plugged into the inside of the watt meter, and then the output plug into the battery in on the speed controller, and then get this closed back up. Then you're going to take the lead coming off of your motor, plug it into the motor output on the on the speed controller. And what I did here was took off the motor head, then I took the red and black wires that were coming out of the motor shaft and connected them directly to the speed controller. I didn't use the blue wire, I just taped off the wire and then shoved it back down inside the motor shaft. That's just the low speed wire, and I didn't need that one. If I turn this to forward and then turn this up to 70, you can see we're at about 90 watts on the speed controller, or we're about 90 watts on the watt meter, and this is tracking how much total watts we've used. And the motor is running in a bucket. I have the motor in a bucket because the water resistance will better simulate what it's going to be like on an actual kayak. Running this motor in the air without any resistance on the propeller ends up pulling basically no power at max speed. I have a time lapse running just so you can see this whole thing going. For this test, to see how much power I consume versus how much power the solar panel produces. I just have it laid out flat in my backyard, as close to what it'll be like on the actual kayak as I can get it. It is a slightly overcast day. The clouds are moving, so there will be direct and then indirect sunlight pretty much throughout this test. Okay, so after looking at the user's manual, it turns out that this charge controller only tracks power produced in amps. So hopefully when I come back in a little while and check it, the amount of amps produced will be at least somewhat similar to the amount of power consumed. We've consumed 12 watts so far. So I'm just gonna let this run and then I will come back and give you guys an update with how it's going. Okay, so as you can see, the sun is on right there and it's putting out 13.6 volts. For whatever reason, when I first connected it, the panel wasn't actually charging anything, so I just turned off the motor, unplugged the panel, then plugged it back in, and now it's working, so it should be good. Since I just restarted it to get it to actually start charging, I just reset the watt hours so we could see how much it's actually drawing, and this will show us total accumulated watt hours. Right now it's 0 because it just started charging. So I'm hoping that actually goes up a little bit. So it is charging at 1.8 amps. But as you can see, we are drawing 7.2 amps. And as the sun comes out, you can see that cloud right there kind of blocking the sun. But as the sunlight changes, you can see that the amps go up. See, cloud just moved a little bit. Now we're up to 4 amps. So I'm gonna let this run now that I know that it's actually charging, and I will be back in a little while to see how it's going. All right, so this has been running for a few hours. I'm gonna come out here and check on it, see how everything is going. I ended up covering the box that the controllers are in, the controller and the watt meter, because when I came out here earlier to check it, the screen on the watt meter had shut off. I'm assuming because it got too hot sitting in the direct sunlight. So anyways, you can see we've used almost 300 watts, keeping an average 7.2-ish amps the whole time. And the charge controller currently putting out 2 amps because the clouds just rolled in, but you can see the battery is still at 13.3 volts. The panel's producing 13.5 volts. It says it's made 70 amp hours, but that doesn't sound right to me because it's only been out here for about 4 hours. So this I don't think is too accurate. You can see it is currently charging. So I'm going to go ahead and turn the test off. You can see the watt meter pops back up to 13 volts on the battery, 13.2. And when the sun comes out, the solar panel starts making over 5 amps of power. So while you wouldn't necessarily be able to run the trolling motor just off the solar power alone, having a decent battery plus the solar panel, you should be able to get or be on the water all day. I'm using a 50 amp hour battery for this test, but if you're able to get out on a mostly sunny day, then you should be able to get away with running a smaller 15 or 20 amp hour battery plus the solar. And unless you have the motor constantly running for the entire day, you should be able to stay out there for longer than anyone would reasonably be comfortable being on a kayak. Overall, with this particular solar system, the installation is super easy. It's straightforward. Everything just connects together nicely, and it's a quick and easy way to get solar power on your kayak. So overall, I'd say that this part has been a success. So if you check back in for part 2, I'll show you how I'm building the kayak with the pontoons to make it into more of a small skiff, and then adding the solar to it. And then in part 3, I'm going to take it out and test it on the water and let you guys know how it goes. And just out of curiosity, I did just connect the motor directly to the solar panel. And as you can see, when the sun came out from behind the clouds, it is actually running the motor right now. Granted, I don't have it connected to the to the speed controller, so there's no way of controlling the speed. but it is able to run directly off the solar panel. Just when it gets cloudy, you kind of slow down a little bit. So anyways, I hope you guys enjoyed the video, and I will catch you on the next one.